View management for optical see-through head-mounted displays optimizes the placement of annotations in order to improve their legibility. In these examples, labels are placed in areas where the contrast between the text and the background ensures good legibility. Labels avoid areas of high lightness and textured areas, and prefer uniformly colored areas. Traditionally, labels are optimized from the point of view of a camera built into the head-mounted display. However, due to the offset between the camera and the user's eyes, the camera view does not correspond to the user's real view through the display. From the user's point of view, labels are placed in different locations, decreasing the legibility of the final layout. We measured the offset between the built-in camera and the user's eyes for 3 commercially available devices to illustrate the differences between the built-in camera view and the user view. Note the varying backgrounds behind the text labels in each view. This effect is aggravated when perceiving labels stereoscopically through both displays of the head-mounted display. The real-world background behind the label is different for both eyes of the users, leading to additional perceptual issues. In this work, we present a novel eye perspective view management approach that takes into account the user's view through an optical see-through head-mounted display. Our method optimizes label placement for both of the user's eyes to ensure uniform backgrounds and avoid perceptual issues. Eye perspective view management optimizes the layout based on a synthesized high-fidelity rendering of the user's view through the head-mounted display utilizing color and depth data of built-in cameras. We utilize a reprojection method that projects the color image of a camera onto a live depth map and renders the view from the user's eye perspective. Eventual artifacts due to disocclusions lead to missing information and are considered by the view management. Here, missing information is indicated using the color cyan. Eye perspective view management optimizes label placement utilizing 4 main criteria. Background uniformity to place labels in uniformly colored areas to avoid visual interferences. Lightness contrast to ensure a lightness difference between text and background to improve contrast. Texture contrast so that labels avoid textured areas which negatively affect text legibility. Stereo uniformity that ensures that both of the user's eyes perceive the same label background behind the text. In a user study, we compared eye perspective view management against traditional view management utilizing the head-mounted display camera view and a baseline method that places labels at a fixed offset from the origin. Participants evaluated the perceived quality of each label, its legibility, and potential interference with the background. We also measured task difficulty and mental effort. Our results show that the novel eye perspective view management significantly improves over the other 2 methods in all measured criteria. For a detailed analysis, we refer to the paper. In summary, our results underline the importance of utilizing the user's true view through the optical see-through head-mounted display to correctly optimize content based on real-world information. Our work also demonstrates that eye perspective renderings are representative of the user's view of the scene and can be implemented with low hardware and software requirements. Eye perspective view synthesis to determine the user's view through optical see-through head-mounted displays opens up opportunities for further research on other use cases relying on the user's true view.